Hi, today let's learn linear programming. For this, what I've done is I've taken a problem from William Stevenson text server problem, wherein it says there is a firm which is trying to produce two new server models, type 1 model and type 2 model. And the manager is interested in maximizing the profits, where the profit per unit of server type 1 model is $60 and type 2 model is $50. And other details which is given here is that each type 1 model requires 4 hours in assembly section, and 10 hours by type 2 model in assembly section. Similarly, 2 hours and 1 hours respectively by type 1 and type 2 models in inspection unit, and 3 cubic feet space for each of these models in their warehouse. Given these resources, limitation of these resources, there are only 100 hours in assembly section, 22 hours in inspection section, and 39 cubic feet space in their warehouse. If this is their consumption pattern per unit, then how to maximize the profit which I get by selling type 1 model and type 2 models within the capacity resource restrictions. Now my first video will in my first video I'll just explain the formulation of linear programming, and in my second video I'll solve linear programming problem using graphical method. Now here, the formulation of any linear programming problem involves three components. We have to list three components. Now what are these three components? It consists, first you will have to define decision variables. Second component is write the objective function. And third component is to list the constraints within which we will be maximizing or minimizing our objective function. Now let us follow the process and formulate linear programming problem for this problem, the given problem here. First component is to define decision variables. Let me consider x1 and call this x1. Let me define this x1 as number of units of type 1 server that I have to produce, type 1 server model that I have to produce to maximize the profit, and let x2 be number of servers, number of units of type 2 server model. This is the first component. Now the second component here is to write the objective function. Objective function for this problem is to maximize the profit. Now usual representation is we use z to represent objective function. Z is equal to 60x1 plus 50x2, because for every unit sold of type 1 server I get $60, and every unit of type 2 server sold I'll get $50. So if I make x1 units and sell x1 units, I'll be getting 60x1 profit, and if I make and sell x2 units of type 2 server model, I'll get 50x2 of profits. The total profit which I will be getting by making and selling x1 and x2 units respectively will be 60x1 plus 50x2. That's why I framed this objective function like this. Now we will have to list down the constraints. There will be three constraints here, one for each of the resources. Let me write the first constraint, which is assembly time constraint. I'll just write this as assembly time constraint. Now, 1 unit of type 1 server requires 4 hours in assembly section. So x1 units of type 1 server will require 4 x1 hours, and 1 unit of type 2 server will require 10 hours in assembly section. X2 units will require 10 x2. So this is the total time taken to manufacture or produce x1 and x2 units of x1 and x2 units, which cannot cross 100 hours which are available in assembly section. Similarly, if I have to frame a constraint for inspection time constraint, now each x1 type of model requires 2 hours in for inspection and 1 hour for x2, and this cannot cross 22 hours in inspection department. Now similarly, storage space constraint, it consumes type 1 server consumes 3 cubic feet. X1 naturally will be 3x1, and x2 type of server type 2 model will consume 3 cubic feet again, so x2 units will be 3x2, which cannot cross 39 cubic feet, which is available in their warehouse. And finally, the non-negativity constraint, which actually restricts value of x1 and x2 to only positive values, because we are saying that x1 x2 should be greater than or equal to 0. If I am going to use a graph sheet, then naturally this constraint will restrict us only to the first quadrant, ignoring second, third and fourth quadrant. This is the formulation of LP model. Thanks for watching my video.